Dear students, in this video we will be solving the sums of exercise 2.1 of the lesson Trigonometry 1. Exercise 2.1. Question number 1. Find the trigonometric functions of 45 degree. Diagram is drawn with a unit circle, center at the origin O, and the terminal arm OP intersects the unit circle at PXY, which lies in the first quadrant. Now to get the coordinates, we will draw perpendicular from the point P to the x-axis, that is PM. And angle MOP is 45 degree. Then we know the third angle OPM is also 45 degree, means it's a isosceles triangle. Then the distances OM and MP are equal, that is modulus of X and modulus of Y are equal. Now by using the coordinates of the origin O and coordinates of P, we have the distance formula x square plus y square is equal to 1, that is x square plus x square equal to 1 because x and y are equal. So 2x square is equal to 1 and x square is equal to 2x square is equal to 1, then x square will be obtained by dividing by 2. 1 upon 2 and x is equal to plus or minus 1 upon root 2. Then substituting this value in this equation, we will get y is also equal to plus or minus 1 upon root 2. Here the point P lies in the first quadrant. So both x and y coordinates are positive or greater than 0. So x is taken as 1 upon root 2 and y is taken as 1 upon root 2. Therefore the coordinates of P are 1 upon root 2 and 1 upon root 2. So we can define the trigonometric ratios of 45 degree as sine 45 degrees y, which is equal to 1 upon root 2. Then cos 45 degrees x, then which is equal to 1 upon root 2 again. And tan 45 degrees y upon x, which is equal to 1 upon root 2 upon 1 upon root 2 is equal to 1. From these values we can directly define the reciprocal ratios. Cosec 45, which is the reciprocal of sine 45, then it will be root 2. And sec 45 is the reciprocal of cos 45 degree. So it is again root 2, and cot 45 is the reciprocal of tan 45, which is 1 only. Seventh one, find the trigonometric functions of 210 degree. Let the measure of angle XOA in standard position be 210 degree. That is standard position we have already learned in the first lesson. That is its initial arm coincide with the x-axis or lies on the x-axis. And we have the unit circle here, and the terminal arm ray OA intersects the standard unit circle at point PXY, which lies in the third quadrant. Now to get the coordinates, we will draw perpendicular to the x-axis, that is PM. Then OM is equal to x or modulus of x and PM is equal to modulus of y. Now triangle OMP is a right angled triangle with the measure angle MOP is 30 degree. Then we know the third angle OPM is 60 degree. Then it is a 30 degree, 60 degree, 90 degree triangle, and OP is the radius of the unit circle, which is equal to 1. Now from this 30 degree, 60 degree, 90 degree triangle, we have the distance MP, that is the side opposite to 30 degree will be 1 upon 2 of the hypotenuse, that is OP, that is 1 upon 2 into 1 is equal to 1 upon 2. Therefore modulus of y is equal to 1 upon 2. And the side opposite to 60 degree, that is OM, is equal to root 3 upon 2 of the hypotenuse, that is root 3 upon 2 into 1 is equal to root 3 upon 2. And modulus of x is equal to root 3 upon 2. We know the point P here lies in the third quadrant. So both x coordinate and y coordinates are negative or less than 0. So we will select the values. X is equal to minus root 3 upon 2 and y is equal to minus 1 upon 2. Therefore, the coordinates of P are minus root 3 upon 2 and minus 1 upon 2. So, we will define the trigonometric functions of 210 degree as sine 210 is equal to y, which is equal to minus 1 upon 2, and cos 210 degree x is equal to minus root 3 upon 2. Then tan 210 degrees equal to y upon x, which is equal to minus 1 upon 2 upon minus root 3 upon 2, which is equal to 1 upon root 3. From these values, we can write the reciprocal ratios, that is cosec 210, that is 1 upon y is equal to 1 upon minus 1 upon 2 is equal to minus 2. Sec 210 is equal to 1 upon x, which is equal to 1 upon minus root 3 upon 2 is equal to minus 2 upon root 3. Then cot 210 is equal to x upon y, which is equal to minus root 3 upon 2 upon minus 1 upon 2. That is equal to root 3. Now 14th sum of question number 1, that is find the trigonometric functions of minus 120 degree, that is the negative angle. Now look at the diagram, and the measure of angle XOA in standard position B minus 120 degree, then we know the direction of the angle is clockwise. So it is 120 degree, then by taking the straight angle, the remaining angle will be 60 degree. Now consider the point PXY on the terminal arm which intersects the unit circle. So to get the coordinates, we will draw the perpendicular PM on to the x-axis. Then measure angle MOP is 60 degree. Then we know the third angle OPM is 30 degree. Then it is a 30 degree, 60 degree, 90 degree triangle. Then we have the measure OM is equal to half of OP, that is half of the hypotenuse is equal to 1 upon 2, and PM is root 3 upon 2, that is side opposite to the 60 degree, that is root 3 upon 2 of the hypotenuse, which is equal to root 3 upon 2. Here the point P lies in the third quadrant. Therefore, both x and y coordinates are negative. So, we will select x is equal to minus 1 upon 2 and y is equal to minus root 3 upon 2. So, the coordinates of the point P are minus 1 upon 2 and minus root 3 upon 2. So, we define the trigonometric ratios of minus 120 degree as sine minus 120 degree is equal to y, which is equal to minus root 3 upon 2. And cos minus 120 degree, which is equal to x, is minus 1 upon 2. Now tan minus 120 degree is y upon x, that is minus root 3 upon 2 upon minus 1 upon 2 is equal to root 3. Now the reciprocal ratios, cosec minus 120 degree is equal to 1 upon y is equal to 1 upon minus root 3 upon 2 will be minus 2 upon root 3. And sec minus 120 degree is equal to 1 upon x is equal to 1 upon minus 1 upon 2 is equal to minus 2. And cot minus 120 degrees x upon y is minus 1 upon 2 upon minus root 3 upon 2 is 1 upon root 3. 18th sum. Find the trigonometric functions of minus 315 degree. And look at the diagram. Angle XOA is minus 315 degree and it reaches to the first quadrant. Then we know from the complete angle is 360 degree. Then from this we will get this small angle, that is 45 degree, by subtracting 315 from 360 degree. And we have this terminal arm intersects the unit circle at the point PXY, and draw the perpendicular PM to the x-axis. Then it is a right angular triangle with the angle MOP is 45 degree. Then the other angle, third angle is also, that is OPM is also 45 degree. Then it is a 45 degree 90 triangle with the hypotenuse OP is 1. Then OM is equal to That is OM means the side opposite to the 45 degree is 1 upon root 2 of the hypotenuse. That is 1 upon root 2 of 1 is equal to 1 upon root 2. Again PM is also 1 upon root 2 because same the side opposite to the 45 degree. Now since this point P lies in the first quadrant, we have both X and Y are positive. So we will take the coordinates. X is equal to OM is equal to 1 upon root 2 and Y is PM is equal to 1 upon root 2. Then the coordinates of P are 1 upon root 2 and 1 upon root 2. So we will define the trigonometric functions of minus 315 degree. Sine minus 315 degree is equal to Y, which is equal to 1 upon root 2, and cos minus 315 degree X is equal to 1 upon root 2, and tan minus 315 degrees Y upon X, which is equal to 1 upon root 2 upon 1 upon root 2, which is equal to 1. Now cosec minus 315 degree, you can directly take the reciprocal of this sine 315 minus 315 degree. So cosec minus 315 degrees 1 upon Y is equal to root 2. And sec minus 315 degree is equal to 1 upon X, that is reciprocal of cos, that is root 2. Now cot minus 315 degree will be 1 only, as it is the reciprocal of tan minus 315 degree. Now more sums are there which are solved in the next video. Thank you.